we're up and running. All right. Hope everybody's doing well. Let's go ahead and start with an attendance ping. Let me know who's here. And any questions to start with?
Well, the biggest problem I have is just running into a lot of segmentation faults. So I had to look up to figure out like usually what are the biggest issues with them. And it's usually me just not creating memory to kind of play around with.
Right.
But I can't come off null pointers. Can you kind of explain what null pointers are?
Well, yeah. So this comes into the whole business of char star versus char variable bracket. 120 for example. So let's say you're writing your test program, and you want to have an input string. So you could say char star in equals HEXLLO. If you say char star out, and then you try to call your remove function, you're probably going to get a seg fault, which is the same thing as a null pointer exception usually. So when you make a declaration like this, char star out, you're saying out is a pointer to a character, but you haven't told out where to point yet. Right? It's an uninitialized variable. All you've done is said this is a char star type variable, but you haven't given it a value. And there's a good chance that the value of this variable out is 0. And when you use a pointer, right, if I try to, access out bracket something, or I try to print out using printf, right, the value of this variable is the location in memory where my characters are actually stored. So if out's equal to 0, my code tries to access memory location 0, and that's going to generate a seg fault. So a null pointer is basically a pointer that's pointing to 0, which is kind of what null means. But inevitably, it's something that's not initialized. If we want to make sure that out points somewhere, you've got a few options. You could use a malloc statement, but that's a little too high powered for what we need right now. So the usual way is just to declare this to be an array of a certain size. As soon as you say I want 120 characters, the system will make sure this points somewhere in memory that will have enough space for 120 characters, and that'll avoid the null pointer. There's lots of messages going on in chat. Let me see. I was doing some problems on Code Wars and kept coming up with using malloc. What is malloc and how do you use it? So malloc, we're going to use a lot of malloc in 222. Basically, if I say char star out, so this is not like something you need to know, but it's topical anyway. If I say something like char star out, right, again, I'm saying out is a pointer to a character, but I haven't given it a value. If I said, out equals 2000, now when I try to use out, I'm assuming that my characters are stored in memory at location 2000. Well, maybe that's an okay location to store them. Probably it's not, though. But what I'd like to do is have out point to somewhere in memory where I know there's, a chunk of characters, chunk of space that's not being used by anything. So typically we would say out equals malloc. And if I wanted 120 characters, I could say malloc 120 bytes. And this will look for 120 bytes in memory that are unused, take the address where that block of memory begins, and return it as the function value. So this would initialize out to point to that chunk of memory. And so that's basically what malloc is. And when we start doing data structures in Winter, we're going to be creating structures while our program is running. When I do this, I'm creating a structure at compile time. I'm telling the compiler, hey, I want out to point to 120 bytes of memory. But with data structures, we're not going to know what kind of structures we want, how big they're going to be, where they should be, until the program's running. And so we'll use malloc to dynamically allocate memory. And that's really the function of malloc. Alright, assess isn't working on the server. Connection refused. Ooh, that could be a problem. Let me hop on to the server. Let's see, Wednesday, 10:05. So it is running. Let's see.
Oh, it's working now.
Yeah, you got 10 out of 10. Cool. So if you get an error when you're trying to assess that says something like connection refused, JavaNet connect exception, it's most likely a temporary thing. It could be that the system is overloaded, or it could be that you have too many processes running. So if your program, for example, goes into an infinite loop and you decided to control Z out of it instead of control C, eventually you run out of what are called process slots, places where the system can create new processes for you. And there's a limit to how many processes you're allowed. And so sometimes that will cause a connection problem. But it seems to be working now.
I think if you hit it right at 10:05, wouldn't the old one have ended and the new one have started? So there's a possibility that there's.
Oh yeah, that's a better explanation. If you did it slightly before 10:05, then it wouldn't have been running yet. So yeah, like this current ODP ends at 10 o'clock tomorrow, and then the next one starts at 10:05. So yeah, there's a 5-minute dead zone in there. And if you try to assess during that, there's no server running. I don't really need a dead zone in there. I just did it because it felt better. And yes, malloc means memory allocation. And it's kind of synonymous with what the new statement will do in Java, which we'll talk about in spring. But allocate in free dynamic memory. So there's a separate area of memory called the heap that is where most memory is kept in some sense. And when you want memory, right, you call malloc and it gives you a chunk of memory. We'll have a lot of fun with malloc next quarter. All right, let's see. Just a reminder. So there's no class tomorrow, right? It's the Clark holiday, Veterans Day. So no classes tomorrow across campus. So I also won't have office hours. And you can check Linux, engrcs.com/schedule. Always has updated hours. So I have no hours tomorrow. I also have no hours 2 weeks from tomorrow, which is Thanksgiving. And no classes Wednesday, Thursday, Friday of Thanksgiving week. All right, let's look at ODP 416. So this was the remove all x's from a string assignment, and the idea here was to use a pair of pointers or a pair of indices, one index that moves you through your input string and a second index that moves through your output string. And those are going to be out of sync with each other. Right? If we just want to copy a string, we just say out I equals in I, and we increment I. But in this case, we're copying from the input string to the output string, but the indices are going to fall out of sync. Because, you know, when we pass an x in the input string, we're not going to increment the index for the output string. So we need a pair of pointers. And so you can code this up with, you know, an input location and an output location. And I initialize them both to 0. The input location is going up to and including the null terminator in the input, because we're going to want to copy the null terminator. And then if the input character is not an x, we'll copy that input character to the output string at output location, and we'll also increment output location. So that's a pretty succinct way of doing this. And there's other ways to do it as well. And so for 417, we're going to do something very similar, but with one small twist to it. And this twist actually makes it more difficult. So this is the remove one function, and it removes a single x, just the first occurrence of an x, from the input string. And so if there's no x's, the input string just gets copied to the output string. If there's no characters, the output string is just the input string, which is empty. But if you find an x, you want to remove it, and then you want to just keep doing, you know, just copy from the input to the output. So any thoughts on how to accomplish this? How to remove the first occurrence of the x?
Exact same code as ODP 416, and then just instead of your if statement for your x, or your checking for not x, add an or in there for some variable that is incremented.
Excellent. So in other words, we're going to use a flag. And that's the whole point of this exercise, is to introduce a flag, or if you like, a state variable. Right? So let's pseudocode 416. And then embellish it. So output location equals 0 for in location equals 0 to string length of in. Right, so here's our main loop, and inside there, for each character, we check to see if that input character is different from an x, and if it is, then we copy the input character to the output. So that's 416. So we can use the same code, but it's going to do different things depending on the state of the system. So think Engineering 250. What is a state machine, right? It's a piece of hardware that does different things depending on what's happened in the past. It's one piece of hardware, but you know, if there's a car sitting over here, it's making this light turn red. If a car just left, it's making this other light turn yellow, right? So this is one set of code that's going to do different things depending on what's happened in the past. Well, in a state machine, we remember what happened in the past using flip-flops. In a software state machine, we remember what happened in the past by using a flag, a variable, which is like a flip-flop. So let me make a new variable, and let's call this 1x done. And I'm going to put a comment here and say set this when we've removed 1x. Alright, so 1x done is my flag, it's my state variable. If it's equal to 0, I have not removed an x from my input string yet. If it's equal to 1, I'm going to say that means I've removed an x already. So now I'm going to do something different in here. I'm going to say if input location, well, there's a few ways to do this. If input location is not equal to x, or 1x done, I don't have to say equal to 1. If I'm thinking of it as a flag, I could just say or 1x done, right? So if either of these is true, if either the character is not an x at all, or, you know, it's an x but we've already removed an x, I'm going to copy it to the output location. And so that's going to let me say, hey, from this point forward, I want you to copy x's. But the first time I encounter an x, 1x done is 0, so this will fail. And, you know, if I've just encountered an x, this will fail, and so I won't copy that character. I won't increment my output location. But now, inside the for loop, I'm going to have to do one other thing, which is make sure I set this flag appropriately. So if in bracket input location equals x, then 1x done equals 1. So I set that flag, and when I set that, that means that the next time I encounter an x, I'm still going to go ahead and copy it because that flag is set. If you just leave 1x done in the if statement, does the yeah, if I just say 1x done, it means is it non-zero. And this is just a C convention, right? 0 is false, non-zero is true. So anything other than 0 would be true. So typically if we have a flag, we use 0 or 1. A lot of things use 0 or -1, where -1 would be true. But if in doubt, or you want to be, you know, super clear, you can always do this. All right, so this should get you ODP 417, right? It does exactly the same as 416, except for this little hook here, which says, hey, only do this skipping over the x's once. If we wanted to skip over the x's twice, right, skip the first 2 x's, we could increment 1x done, and then when 1x done is equal to 2, right, we would start copying all the characters, whether it's an x or not. And we would need to be a little more careful with this line, but for us, we don't care. We just want to know, have we seen an x? All right, any questions about that?
I was gonna write the if statement for if the input is just x. I forget what it's called, but it's like an if statement, but you can draw like you can write on one line. It's like a kind of operator.
Oh, like a ternary operator?
Oh yeah, ternary operator. That's what I'm thinking of. Yeah. Is that a bad idea?
Let's see. I'm not sure exactly how I would use that in here, because we actually want to do two things when we find a non-x character or we're copying anyway. We want to copy this into the output, but we also want to increment the location. And I'm not sure I see an easy way to use this kind of construct for that, but there might be. This is nice when you want to try to get rid of usually an if-else. So, you know, if this is true, then set x equal to this, else set x equal to that. That's what kind of screams out for this. We could just say x equals condition, true value, colon, false value.
Wait, so, sorry.
So I'm assuming that it's best to work with, if it's like integers, then not be the best scenario to use the ternary operator?
It works well with integers or characters or floats or anything else, but here's an example of the ternary operator. So suppose we want to say, you know, if string length of str is bigger than 0, I don't know, you know, x equals 5, else x equals 0. Right? So I could rewrite this by saying x equals, and then here's our condition. And then the ternary operator, and so I put down the value I want to assign to x if this condition is true, which would be 5, and the value I want if it's false, which would be 0. And it's just a more succinct way, a more compact way of writing an if-then-else statement. So in Kernighan and Ritchie's C book, they give the following example, I believe. Print, you took %d stick %s. So number of sticks. So let's say you took 5 sticks. You wanted to say you took 5 sticks. If you took 1 stick, you wanted to say you took 1 stick without the s at the end. So I use num to print out, you know, my integer value here, and then for the string %s, I could say, you know, num equals 1 empty string :s. All right. So what does this do? It says if num is equal to 1, I want to have just an empty string, quote, quote, right here. And so I'll say you took 1 stick followed by an empty string. So it says you took 1 stick. If num is some other number than 1, if num's equal to 5, I'll print out a 5 here. You took 5. This condition is false, so this piece of my expression becomes just an s. And so I'll print an s in place of the %s, and it'll say you took 5 sticks. So that's a nice use of a ternary operator, because the alternative is to have 2 statements. If num is equal to 1, print you took %d stick, comma num, else print you took %d sticks, comma num.
Do you know if there's some truth to if you use a ternary it executes faster? I've heard this before, but I don't know if it's true.
It's possible. I can see cases where that could be true, but it really depends on the compiler. And so think about, you know, if you've done Engineering 270, how would you write assembly language to do this operation? And sometimes, you know, when you write a statement in C, there's multiple ways it can be done in assembly language. So this is also kind of a freebie. So in C, for example, we can say I++, and it means add 1 to the value of I. Of course, we can also say I equals I plus 1. And they do exactly the same thing, right? The result of either of these is that i's value has been incremented by 1. But in the earlier days of writing compilers, right, to notice that this is an increment, you would need to, you know, parse it out and see that this is the number 1 and say, oh, I can just do an increment. So you can put the burden on the programmer. And if the programmer, yeah, or I plus equals 1. So if you tell the programmer, hey, do this when you want to increment something, the compiler has a really easy job. It sees this and it changes it into the assembly language instruction, increment file register I, if this was, you know, Engineering 270, pick processor. Whereas this instruction in general would say, you know, move literal into W1 and then add W to file register I. And so this, you know, doesn't let you do anything different from what you can do with this, but it's a way to tell the compiler, hey, by the way, I'm not just adding some arbitrary number to I, I'm adding 1 to I. And so that's sort of what the ternary operator can do also. There's cases where the compiler might be able to do a more succinct assembly language version of your intention, knowing that, you know, this is going to be either this or that. Yeah, we're on kind of a further down the rabbit hole aspect of ODP 417, but pretty removed from it.
Wait, so, is it, the way I read 417 was that when you first encounter an X, you skip it and then copy the rest of the string, regardless
That's correct.
Of whether or not it's an X or not.
Mm-hmm. Exactly.
But what I saw just before we went on this side topic is that we're stopping copying once we first see an X.
Nope, we're still copying. So if our character, right, so we're going through all of our input string. We're setting this flag to 0 initially, we're clearing it. If our character is not X, we're definitely going to copy it. The first time we encounter an X, we'll set 1x done equal to 1, and after that, whether our character is an X or not, this condition is going to be true, and so we're going to copy from the input to the output. So once we hit an X, this condition happens, this statement happens every time we go through the loop from that point on. And there's other ways you can do this. You can use the string copy command to sort of coerce that function into copying the rest of the string, but don't try to do that, right? Try to come up with an algorithm like this, right? That just kind of does, exactly what you would want to do if you were, stuck on a desert island trying to remove the first X from a string. How would you do that? That's what we want to code up. Let's see. Chat question. So there's an earlier question about not using a flag, and I'm not sure I understand your proposal, but try it and see if it works. You might be using a flag in some other form that doesn't look, as explicit as this, for example. But code it up, try some test cases, and see if it works. And if it doesn't work and you try to fix it, you'll probably discover the concept of a flag in there. Let's see. Yeah, you're welcome. So be careful with this. So someone's asking about using a ternary operator. So what we don't want to do is say if this character is an X, set 1x equal to 1x done equal to 1. Otherwise, set it equal to 0. That's not what we're after. We want to set it to a 1 the first time we encounter an X, and we want to leave it at a 1 for the rest of the function, right? So if you use a ternary operator and you set flag equal to 1 or 0, I think you're going to end up resetting it on the next character that's not an X. And we want this flag to say, hey, I have seen an X sometime in the past. And after that, whether we see an X or not, we still want that flag to be set. Cool, that sounds plausible too. And yeah, these flag values could be 1 and 0. It could be a delete X flag that you initialize to 1, and after you've deleted an X, set it to 0. And whatever's going to make the most sense to you is the way to go. All right, let's take a look at ODP 418. Which will be due Friday morning, but we don't have class tomorrow, so so we don't have class time to talk about 418. So let's talk about it right now. And 418 is kind of a mix of some of these other ODPs. 418 is a move function, and it basically takes the first character of a string and moves it to the end of the string. And this is tricky in its own way. But the concept is, you know, if you have hello, it's returning into the string ELLOH. And again, don't try to necessarily think of some super clever way to achieve this. Don't try to think of it in terms of, you know, if I do this, then it'll move the string down and so on. We can do this in a very sort of direct way. So, you know, I can have an initial output location equal to 1. I can have an initial input location equal to 0. And I can iterate over all of my input characters. And I can just say out bracket output location plus plus equals in, let's see, we're removing the first one. Am I backwards? HELLO. I want to go to ELLOH. Alright, so for input location equals 1 to string length of in minus 1. So I'm going to start my my input index right here, ELLO, and I'm going to have some output location which starts at 0. I'm going to do output location equals in input location, and then increment the output location. Alright, exactly the same kind of structure that we've had in these past few ODPs. A pair of pointers, one which points to the input string, one which points to the output string. And the only difference here is I'm starting my input index at this second character, the E. My output index is at 0, so I'm going to copy this to here. I'm going to copy the L to here, the second L to here, the O to here. And then I've got one extra step at the end. So when I'm done with this, output location will be pointing right here. I'm going to want to do output location equals in 0, so that this one gets copied down to here. And if I do a plus plus on the end, then I can go ahead and set my null terminator. Keep my output as a string. And this works great, except for edge cases. And this will not work with an empty string, I don't think. It will not work with a string of length 1, I don't think. It should work with a string of length 2 or more. But you're going to want to play around with this, right? Or come up with, you know, totally your own algorithm. But the guts of it is pretty straightforward, right? Just march through your input, copy character I to position I minus 1 in the output.
What is an edge case?
Oh, an edge case. Thanks. I always use that term, and I haven't defined it. An edge case is something that happens, something that breaks the general algorithm, right? So let's say that you have a way to add up the number of integers in an array. And so you're going to do a loop, and you're going to start off at 0, and you're just going to add each integer to a running sum. But maybe the way you've written your code, if that array has no numbers in it, if its length is 0, maybe your code breaks, right? So maybe you wrote your code like, you know, sum equals data bracket 0 for I equals 1 to such and such, sum equals sum plus data I. This code would break if your data array contained no numbers. right? Because I'm assuming I have at least one number which I'm using to initialize my sum to. And so an edge case for this algorithm would be the case where the array had a length of 0. So yeah, it's something that happens infrequently or uncommonly, but it's also something that breaks an assumption that you've made in your code, perhaps, right?
Could be in math too, like all prime numbers are odd except for 2,
Yeah,
which is the edge case.
that's an edge case, exactly. So something that goes against an assumption or something that is usually true. And so in this case, for example, I just want to copy from element I to element I minus 1. Well, I can't do that when I equals 0, because that says copy from element index 0 to index minus 1. And really I want to copy the element at index 0 to the end of my string. So I have to start from location 1. But if there is no character 1, if my string is empty, right, trying to access the character at index 1 is going to throw a seg fault. So that's a case that I have to handle separately, which is where my input string has a length of 0. And if my input
results in ugly code.
yeah. So it can make your code less beautiful. Because you got, well, if this happens, do this. If this happens, do that. Otherwise, here's this beautiful code. All right, so copy from, each position to the position before in the output, but definitely check the cases where your string is empty. If your string's empty, then your output string should just be empty also, because there's nothing to copy. If your string consists of a single letter, well, then your output string is going to look exactly like your input string. If your string consists of a pair of letters, your output string is going to look like that. It's just going to reverse it. If your input string is A, B, C, then your output's going to be B, C, A, right, where that first letter is getting moved to the end. So I think these are the two special cases you need to think about. And that can be as simple as, if the string length of the input's less than or equal to 1, just copy the input to the output. So how do we detect an empty string? So this is certainly one way. You can see if the string length is equal to 0. We can also see if the first character is equal to the null terminator. And that'll also tell us. We could also string compare to an empty string. And that'll also tell us. But we can't compare strings using a double equal sign. If we did, we could try to equal, double quotes. And that won't work. And we cannot double equal to a \0 because that's a character and in is a string, so those aren't even comparable. But any of these ways would work. Getting IO exception broken pipe message when trying to assess 418. So broken pipe is probably your program exiting too soon. And typical condition for that might be a seg fault. So, again, you should be running test code before you try to assess. Just write your own main program, and then if you get a seg fault, it'll jump out at you, and then you can compile with a -G and run this in GDB, and that'll tell you exactly where the seg fault is happening.
Sure, because I tested out this program before I set this before 17, so I'm still getting the same issue.
What issue is that?
The same issue that I was having with the kind of Java errors. remember correctly.
Let's see.
Yeah, they like the fucking pipe one.
So again, it's probably a seg fault. Make sure you're testing your code with an empty string. Make sure you're testing it with a string of length 1. Make sure you test it with a string of length 2. And then test it with, some general strings. Like hello or something
it
like
still
that.
works. I just tested mine again and it works, so it's definitely your code.
So your test code is working?
Oh, no, sorry, I was saying I did the assess again, and it's still working, so it's definitely their code and not the assess.
Okay. 417 just returns an empty string for my test code. Is it supposed to, are you trying to remove 1 for an empty string? So,
my test code has the input being xxx, hello, xxx. And I'm trying to remove first x of encounters, which is the,
right.
So it's supposed to print out xx, hello,
Right.
xxx.
Right, and is that working in your test code?
Apparently not, because like I have like the if and also set up for like it being like the index not having a x
Okay.
over.
So this is a really great ODP to work with GDB on, right? Assuming you have an algorithm, so you have some pseudocode or a flowchart or something that describes to you what the code should do, right? Now you can run this in GDB and step through line by line using step or next, and after each instruction, make sure that what's happened is the same thing that you think was going to happen according to your pseudocode. So if you think it's going to set a flag at this point, right, execute that line in GDB, and now print the value of your flag. Make sure it's set. The next time through the loop that you encounter an X, if you expect that flag to cause it to copy the character, right, go ahead and step through that if statement in GDB. Make sure that it actually copies the character. If it doesn't, you found where the bug is, and it's probably a bug in that if statement. And so now go back and write some different code that just uses, that if statement in itself, and keep drilling down to try to find where the problem is. And this is a really good ODP for that.
Okay, so how do you compile? Can you tell us again how you compile it and then run through it in GDB?
So GCC-G. And this works best if you put everything in one file, so put your main program in. If they're separate files, compile each one with a -G, and do, the rest of your GCC line as usual, and then to debug, say GDB, whatever you're calling your main program, and say start, and then you can say next. If you want to go to the next line of C, you can say step. If you want to go into a function call, you can say print, to print the values of variables, and that's usually enough to get you most of the way there.
Okay.
All right, good. So this is all good, good stuff to be working on. So again, no class tomorrow. We'll meet back on Friday. And Friday I'll talk more about some final things that might help you with PA4. We got a few minutes. I'll mention these shortly. And then Monday we'll be doing presentations in class of people's PA4. People's or groups. I've only gotten about 3 groups, I think, from people, and I think today's the deadline for declaring you want to be in a group. So if you haven't told me yet about your group, go ahead and send me that email. PA4 is due on Monday, and it's going to be presented to the class by one or more person from each group, or if you did it alone by yourself. and I'll post an order of presentations sometime later this week. Let's see, we got 2 minutes left. So we talked about grep yesterday. We talked about awk a little bit before, and don't underestimate the value of awk. So if you have a variable like this and I wanted to pull out the month, right, I can do something like echo $D, pipe it into awk. And awk normally separates by spaces. I'm like staring at this and it's not visible. Let's see. Alright, here we go. So if I say like D equals date, and I echo $D, right? If I want to pull off some piece of this, like say I want to pull off that November piece, I can echo $D, I can pipe it into awk, and I can say print field 2, and by default, fields are separated by spaces. So this would be field 1, this would be field 2, and so if I do this, that'll get me November. And if I say something like month equals back quote all of that, now I've got my month inside a variable. So as
that field being separated by spaces.
yeah, so you could say awk dash field separator and then put in whatever character you want. So comma for CSV, slash for dates, things like that. And so as you are processing the data in your calendar file, right, you may want to split it up. You can build your calendar file entry pretty easily by just, using the echo statement. But if you've written a file line that has like a date and a time and a calendar description, right, you may want to break it up into pieces. Awk is a really useful way to do that. And we talked about it in another class, so you can go back and review that. Yeah, if you want to do any additional features on PA4 other than the ones listed there, you have to run them by me and make sure that they're acceptable. So yeah, shoot me an email to ask about that. And to tell me that you're working in a group, make sure I get that email like right now, because I don't know what time I set the deadline, but it was sometime Wednesday. So let me know what groups you're working in today at the latest. All right, we are out of time. I will see you next time.